Welcome, today we talk about resistor.
A resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. The symbol is. The unit is. Also have different types of resistor symbols. Let's see types of resistors regarding packaging. First one is linear resistor, it divided in two parts. First part is variable resistor. Potentiometer resistor, rheostat resistor and trimmer resistor are members of variable resistor family. A variable resistor is a device that is used to change the resistance according to our needs in an electronic circuit. It can be used as a 3-terminal as well as a 2-terminal device. Mostly they are used as a 3-terminal device. Variable resistors are mostly used for device calibration. Fixed resistor is second part of linear resistor, and fixed resistor has 4 parts. Carbon composition resistor is one of that parts. Applications include the protection of circuits, surge or discharge protection, current limiting. Next is wire wound resistor. Wire wound resistor is used in a variety of applications and in particular as a power resistor where larger amounts of power need to be dissipated. Next is thin film resistor. It divides as carbon film and metal film. Thin film resistors are usually used for applications where a higher precision is required, such as for measuring and monitoring equipment within the medical and aerospace sectors, audio applications, computer chips, power supply converters. Last part of fixed resistor is thick film resistor. It divides as fusible, ceramic film and metal oxide. Thick film resistor elements become glass-like after firing, which means they are inherently impervious to moisture. Thin film resistors are typically used for applications that require high stability, high accuracy, or low noise. Second resistor type is nonlinear resistor. It has 4 parts. There are thermistor, LDR, varistor and surface mount. We know that nonlinear resistors are those resistors where the current flowing through it does not change according to Ohm's law but changes with change in temperature or applied voltage. Now we focus about resistor color codes. For a 3-band resistor color codes, the first 2 bands always denote the first 2 digits of the resistance value while the third band represents the multiplier. The 4-band resistor color code is the most commonly used resistor. Similar to the 3-band resistor, the first two bands always give the first two digits of the resistance value. The third band represents the multiplier while the fourth band represents tolerance. As the 3-band resistor has no fourth tolerance band, the default tolerance is taken to be at 20%. Sometimes for a 4-band resistor color code, the tolerance band can be left blank, resulting in a 3-band resistor. Now we discuss about preferred resistor values. Resistors are available in a number of standard ranges, often called preferred values. These ranges, or series, are set out by the Electronic Industries Association, EIA, and RE3, E6, E12, E24, E48, E96 and E192. The number after the E denotes the number of values the series contains per decade. The E3 and E6 series aren't really used these days. The most common series is probably E24. The series are logarithmic and are derived from the resistor tolerance. Resistors with a tighter tolerance can have more values in the series that won't overlap one another. The series are sometimes referred to by the tolerance, the two being related as follows. Okay, let's go to discuss Ohm's law. This simple formula describes the relationship between voltage, current and resistance as follows. Voltage dropped across a resistor, V equals IR, where I is in amps, R in ohms. This can be rearranged to give current or resistance if voltage is already known. Ohm's law. Power dissipated in a resistor, P equals I square, R or V square, and divided by R, where P is in watts. Always make sure the resistor's power rating is not exceeded. Let's talk about how to calculate resistors in series. Putting resistors in series increases the total resistance. R equals R1 plus R2 plus R3 like as. Note that the total resistance should be greater than that of any of the individual resistors. Finally, we discuss regarding how to calculate resistors in parallel. Putting resistors in parallel reduces the total resistance. Note that the total resistance will be less than that of any of the individual resistors. Subscribe you and me, click bell icon. Thank you for watching my video.